So experiment 1, dissolving a salt. The first method point is add 50 centimetres cubed of distilled water, so that's been measured out inside here, to a polystyrene cup, that's this thing here. I'll put the cup inside a clean, dry, empty beaker like that. Now it says to use this thermometer to stir the water for 2 minutes. So I'll use the thermometer, stir the water for 2 minutes, and come back to you when we're about there. So I've been stirring this for 2 minutes or so now, and the start temperature, which we have to record then, is 17.5 degrees C. 17.5 degrees. The method then says to add 3 heaped spatulas of potassium chloride, that's this substance here, 3 heaped spatulas of potassium chloride to this polystyrene beaker. So 1, 2, 3 heaped spatula loads of that, like so. Stir the mixture using the thermometer to dissolve that potassium chloride and take note of what happens to the temperature. Give it a good old stir, looks like it's dissolved nicely. Take a note of what happens to the temperature. It says if the temperature rises, record the highest temperature. If the temperature drops, record the lowest temperature. Well, the current temperature is 10, 11, 12.5 degrees C, so it looks like this is dropping. So I'll just give it another stir and give it a moment, see if it gets any lower than that. It's now dropping to 12.0 degrees C. See if it gets any lower. Seems to have stopped changing now. So we'll go with that 12.0 degrees C as the final temperature. Experiment 2 is a neutralisation reaction, and to show this one we're going to use this piece of apparatus here, which is a thermometer, but it's a thermochromic material, so it changes colour with temperature. So hopefully you can see here that the one that's highlighted green is 18 here, which means that the current temperature of that strip is 18 degrees. 20 is a little bit reddy orangey and 16 is a bit blue, so that means 16 is lower than the true temperature and 20 is higher than the true temperature, so the true temperature is somewhere around 18 degrees C. So the first thing I'm going to do is take some 2 molar hydrochloric acid, that's reasonably concentrated hydrochloric acid, and just pop a tiny dot nice and carefully on each of these numbers, just like so. So nice and controlled and careful adding. You can see the 18's gone really green now, perhaps. So I'll just keep adding all the way up to the 40 and give it a moment to respond. And the starting temperature looks to be somewhere around about 18 degrees for that acid as well. The next thing I'm going to add is 2 molar sodium hydroxide solution. Now this is corrosive, so I'm wearing splash-proof goggles for this experiment, so that's important to wear splash-proof goggles. So let's just make a note of the starting temperature and let's see whether the final temperature, when I neutralise the hydrochloric acid with the sodium hydroxide, is higher than or lower than the start. Let's have a go. So I'm just adding a small drop sodium hydroxide solution to each of these spaces. Doing it as quickly as I can. And let's give that a moment to settle down. And give it a moment for the thermometer strip to respond. And now you can decide whether the final temperature is higher than or lower than that starting temperature of 18 degrees C, and therefore can deduce whether this is endothermic or exothermic. So this experiment is experiment 3. It says a displacement reaction. First method point, add copper sulfate solution, that's the solution I've got into here, into a small beaker until it is half full. So it's a 100 centimetre cube beaker, so that looks about half full to me, close enough. Use a thermometer to stir the solution for 2 minutes, then measure and record the start temperature. So I'll pop the thermometer in, I'll stir it for 2 minutes, and I'll come back to you when that 2 minutes is done. So it's been about 2 minutes now, and the thermometer is reading 18 degrees C. So the next thing I'm going to do is add 3 heaped spatulas of zinc powder, that's this substance here, to this beaker. So I'm just going to lift that thermometer out so that it doesn't drop, it doesn't knock the beaker over whilst I'm doing this. 3 heaped spatulas of zinc. 1, 2, 3. That down there. And then it says stir the mixture using the thermometer. Take note of what happens to the temperature. Give it a good stir. The next thing it says is if the temperature rises, record the highest temperature achieved. If the temperature drops, record the lowest temperature achieved. I'm looking at this thermometer and the temperature is rising fairly rapidly, so I'll keep stirring this. It feels warm to the touch actually to my hands there. Keep stirring. Still going up. Slowing down but still going up. Still going up. And that seems to have stopped now at 51 degrees C. Now we could let that settle out and see if you can see any different observations. So we'll let that settle for a few moments and then have another look at it. So this one is experiment number 4, a combustion reaction, so burning a fuel to release heat. I'm taking the mass of a spirit burner and its lid. So the starting mass of spirit burner plus lid, 246.40 grams, 246.40. Now I've already half filled this can with water and clamped it above the spirit burner. Notice the spirit burner still got its lid on and is not lit yet. And I've been asked now to measure the temperature of the water. So I've got a thermometer here, pop the thermometer in that water now, just give it a little stir, just give it a moment to think about that temperature. It's just dropping slightly because it's quite a cold day in here, so the water's fairly cold from the tap. And the starting temperature on this thermometer is 17 degrees C. 17 degrees C. It then says to remove the cap, immediately light the spirit burner and put it underneath the can for 2 minutes, stirring water with the thermometer continuously. And then after 2 minutes, extinguish the flame. Now the absolute time of heating doesn't really matter too much here, so I'm just going to kind of keep an eye on the clock that I've got on the wall behind and do approximately 2 minutes. So take this match, light the match, lift the lid, pop it on and give it 2 minutes. We'll come back in 2 minutes when that's been doing its thing. So this has been heating for about 2 minutes now. In fact, it feels quite warm when my hand is just here. I'm just going to extinguish the flame using the lid like so. And it now says that I need to, just a second, I've looked at a different experiment here. It says to record the mass of the spirit burner with its lid on and record the final temperature of the water. So the final temperature of the water is 28 degrees C, 28 degrees C for the water, and the final mass of the ethanol spirit burner with its lid, 245.19 grams, 245.19 grams.